Today, we got a lot of homework. I told you we had a lot of homework questions. So we also have a lot of homework to go over. And then we got an entire day of new stuff. First, let's go over the homework. This is question one. What's the average amount of strikes thrown in each attack zone? Rename this to attack zones. This should be pretty easy. We did this all with the group by and rename stuff, right? So I'm just gonna create a new data frame here. DF attack. And I'm going to select attack zone, and I'm gonna select is strike, just like how we did up here, right? When we were creating really either of these things, either of these group bys, I'm selecting a specific set of columns, right? Like I'm using only 3 columns in this case. Okay. And I'm doing the group by function. So we did this all in day 3, right? So we put this in there, then we do the group by. And then I only need a group by attack zone. You could put this in a list if you want, just like how we did it in the homework before. You could also leave it outside of a list. It's better practice to put it in a list. But you could go either way. Doesn't matter. I'll do as index false. And this is what I say, average, so I'll do the mean. Okay, so if we take a look at the head here. Oh, sorry, I was doing this overall attack zone, so don't need the head. There's only 4 of them. You get something that should look like this, but we need to rename. Just like how Fetty said, we gotta rename. So we'll rename, the column is a strike. And we want this to be attack zones, a capital A, capital Z with a space. Unlike, it typically isn't great practices to rename your columns with spaces and, fairly colloquial English like this, but a lot of the time when you're presenting a table outward, reporting or something, you could actually format a lot of it in pandas and then export it if you want to do it that way. Not a bad idea, but if you do it this way, you get to rename is strike, which I believe is oh, sorry, we're supposed to rename attack zone, not attack zone to attack zones. Okay. So I'll rename attack zone, and notice how when I did that, it didn't overwrite is strike, because we haven't saved it to any variable yet, right? So I'll save this over our old DF attack. Now we have attack zones, and then is strike, and then the percentage, right? What's after is as index? Okay, so this is something people were asking about too, about how do you format something so if it's on one line, like it gets a little long. Yeah, so in day 2, if you wrap things in a parentheses in pandas, you could actually end up getting access to like, some multi-line kind of smart indenting of your .loc function. So you can cut through and then also separate things on different lines if it makes it more readable. So I'll do that here. I'll just wrap this in a parentheses, and then we'll separate some of these things onto different lines. And you could even go further, like separating the comma-separated keyword arguments onto separate lines as well. And those are also going to come with their own indent, right? But I don't think we need that here. Hello, all too swift. So here's what it looks like. It's a loc function. We're selecting attack zone and is strike. We group by attack zone. We do as index false, just like how we did in on the previous day, and then we're aggregating by mean. So that's homework 1. What's the average amount of strikes in each attack zone? it is this. So you should be getting Chase 20%, Heart 68%, Shadow 56%, and Waste 14%. Okay, we renamed Attack Zone to Attack Zones with a capital A and Z with a space in between. This is overall, not for each pitcher. So if you did a group by Attack Zone in pitcher name or pitcher ID, which is just the keyword pitcher, that's okay too, but full credit, just do the easy way. You just need to group by one thing here. All right, homework 2. For each Reds pitcher, how many times do they throw into each attack zone? Between release speed of 80 and 90 miles an hour, what were the average strikes in each attack zone between 80 and 90 miles an hour? Merged the number of times thrown in each attack zone and the average strikes in each attack zone for each pitcher into one data frame. So day 3, we actually did both of these. So we did the count. Right? We counted how many times something happened, and we also took the mean, right, of how many times something happened as well. Right? So we did 2 group bys, and then we did the merge. So this is all stuff we did on day 3. So I'm just gonna break this up into 2 data frames. We'll do a df loc. The first one is for each Reds pitcher. Oh, so I need to do is Reds pitcher, which we created, I believe, on day 1. And then it's also between 80 and 90 miles an hour. So I saw some people doing this a couple ways. I'll show you the way that I do it. And if you didn't do it this way, that's okay. Because I saw some people do it where it's like between 89 and 90 miles an hour. So some people did like less than or equal to 90. So you could rename this whatever you want, but I'm just going to use df1 in this case. And then some people did this way. So between 80 and 90 miles an hour. You could have included 80 and 90, or you could have excluded it. Including it, I suppose, would have been the safer way because I didn't specify inclusive or exclusive. So some people did it this way. And if you do it this way, and you get a shape... Oh, crap. Your shape should look something like this. 11413. The way I would have done it, which would have taken maybe a little Googling, which... in my opinion, that is definitely encouraged, is using the between function, which I didn't show you, but if you Googled for this statement, between release speed 80 and 90, you're going to get the answer of 11143 as well. So this does the same thing as inclusive, so equal to or greater than 80, and equal to or less than 90. So how many times did these pitchers throw into each attack zone? Okay, so we're looking for pitcher name, and then attack zone, and then some of you might have ran into this problem. Like if you just did pitcher name and attack zone and didn't have some column to aggregate over, it might not have aggregated over for you. Some of you I saw in the Discord putting in like a is strike as your numerical column, and that's perfectly fine. I'm doing that right here. So pitcher name and attack zone. If you want to do just the pitcher ID, you could have done that too. That's actually probably more acceptable because you never know about people with the same name, right? They would be grouped together. Okay, so we have is strike. This is how many times did they throw it with a release, and then how many times. So this is a count. So we'll group by. And then this is pitcher name and attack zone. And remember, we have the filter on is Reds pitcher 1. And we'll do the count. Okay. And we'll put that into df1. So Your DF1 shape should look something like 147. If we look at the top head, 20. You see Chase Anderson throwing into the chase zone 70 times. Then we got heart zone 42, shadow 113, and waist 16. So if those sound like numbers you got, then you're on the right track. So again, like I did above, and I did this on day 2, I'm just gonna make this a little more readable. Okay, so this is a loc. We're doing this as our conditional statement, and then we're splitting by this list. Then we have the group by and the count. Okay, so we could do all of this again, but instead of a count, we'll do the mean. And we can look at the mean as well. So if you're getting Chase Anderson 22.8, 80.9, 58.4, and 0, you're in the right place. And I believe that's what the question was. What were the average strikes in each zone? Yep. So this is the same statement. Red's pitcher between 80 and 90. And then it was a merge the number of times thrown into each attack zone and the average strikes in each attack zone for each pitcher into one data frame. Okay, so this is just a merge. But the trick here is that DF1 has a column named isStrike. And DF2 has a column also named isStrike, so you gotta flex your rename so isStrike, and this is the average. And then DF1, this is the count, just like how we did on day 3. And then if you have DF1 with the count and DF2 with the average, assuming we grouped by everything equally, which I know we did because I made this homework, you could just merge. And if you just do the merge, because we know the 2 data frames and how we're like subsetting all the data, this wouldn't hurt you. You wouldn't get penalized by anything here. You get all your information correctly. Your data frame doesn't blow up. It's fine. But best practices, just like how I was talking about best practices in homework number 1, question number 1, putting thing in a list, even if it's one thing. For your merge, stating what you're merging on is important in my opinion. Because when you're in code review, someone is probably going to ask you, well, what are you merging on? Right? And if you just implicitly merge, it's harder to review. So being explicit about what you're merging on is pretty important, in my opinion. Again, different places may code differently. Your coding style as a hobbyist might be different than your coding style as a professional. We definitely use both on this stream. So DF1, DF2, when you merge it, we can create a DF, we'll call this pitcher attack. Okay. And that's the full thing. So now we've created one data frame for count, one other data frame for mean. We renamed the data frames, and then we merged them. Some people did it all in one go. So I saw some people do this where rather than using group by count, they used group by ag. Okay, I saw some people do it this way, where they use group by ag, which is fine. You could use group by ag. You just need to state a few more things in your group by ag. Because the aggregation, it will allow you to do whatever you want, and it's a lot more flexible than just your one-off like mean. But it requires you to input things. Like if you're gonna group by mean, then you could do that. But if you want to group by mean and count, you know, you could do that too, but you also need to define some things, right? So you need to, actually, if I put this in, I think, yes. If I put this in a list, just like what I was talking about with the group by here, if you put things in lists, they work better. So you can see here, you could get the mean and the count at the same time. And here, you're getting the count and the mean or the average, right? So you could even flip this around for those who are like, well, Mr. Streamer, it's not in the right order like you have underneath. So here you go, here's the right order, count, and then the average, count and the average. And some people were like, in going over this homework when they did this problem, they're like, oh, well, how do I deal with the multi-index? How do I deal with this multi-index? I know as index false does it in the group by, but it's not doing it here. What can I do? You can do two things. Okay, the first thing you could do is reset the index. So resetting the index flattens out your rows. So now instead of multi-index at the row level, if you reset your index, you get those columns back. And the other thing you could do is you could reset, I think you could reset index, I think this is gonna work. Axis 1. Oh, it doesn't work. It doesn't work. I thought that was gonna work. Then the way to get this out does require a little more effort, but I'll go over what that looks like since some people did it in the Discord. So you could go columns, right, and get your column names, and you can see that it's in a multi-index. So this is for the people who used ag. If you didn't use ag, you don't have to care about this, but for the people who did use ag, you could do df columns, and you could actually, since this is an index, right, a multi-index, just like the row level index was a multi-index. There's actually a special function in here called two flat index, I believe. So this starts to flatten out your index. Okay, so now we're no longer in a multi-index, now you have a two flat index. In order to get the name out of each of these, it does require a little more effort, and I might leave that up to y'all to figure out how to do it. I do have a method to do this, but we didn't go over it before, and it's a little more advanced than what the bootcamp entails. So for the sake of confusion and pacing, I will leave y'all up to however you want to deal with the two flat index. But if you do want to go the ag route as opposed to just making two different data frames and merging, you can absolutely do that. This is actually probably more time and resource lighter, efficient than this. But this makes us repeat some of the basic things we've done already, right? So in my solution here, based off the stuff that we were learning already, just two different group bys, put that into two different data frames, rename, and then you can merge. So that's question number 2. We see some answers in the Discord already. Let's do 3. Question 3 was the one that kind of tripped up a lot of people. And there were, I'm not gonna lie, it was definitely difficult. So for batters, which pitch type did they hit for home runs? For pitchers, what is their most frequently thrown pitch type? So this is 2 different questions, 2 different data sets here, okay? So the first one is asking for home runs. I saw a lot of people do a lot of different creative things to get home runs, but from Hume, home run, from the initial day when we created columns, the way that I was showing everyone to do it would be to initialize the column, and then in events, find home run. And if you did it another way, if you set things equal to each other and then filled, or if you had some different logic to get this information, that's completely fine as well. Oh, sorry, is home run. We'll go is HR. Okay. So we have is home run 0, and then anytime there is an actual home run, we'll turn all the values in the column is HR into 1. Okay. And then when we look at the head of our data frame, you'll see at the very end here is home run. And you could always double check. Remember, we did all of this on day 1. You'd always double check to see at what point was there a home run in the first 50 rows. There was 1 home run down here, row 45, index 45, where Reaver San Martin threw a pitch to Franmil Reyes, and he hit that for a home run in 2022. Okay, so we created this is home run column. Next thing we'll do is we'll do another group by. And this is, what was it? For batters, which pitch types do they hit for home runs? So we're going to use batter name, not pitcher name. And then it's which pitch type, so pitch name, which is what we've been using, do they hit for home runs? And is HR. And then we'll group by again. He is hurt right now. He is hurt. As index false. And for some people, when you're doing is home run, which ones did they hit for home runs, you could also just look for is home run, is HR, true, right? Or you could have just directly done that here. You could have put this in here. I've seen all of these different ways in the Bootcamp help section. I've seen all of that. So if you did it this way, and then you did a group by count, that's fine. That works. That's totally fine. Another way you could have done it, is if you did all of this, and then you did like a group by sum, you could have done it that way too. A group by count. And so here's all the times that you hit a home run, given this fastball, curveball, cutter, slider. These are the different times Willie Adames hit a home run, how many times he did it, and the type of pitch he did it off of. Again, if you did this where you did nothing and you did a sum, your data frame might look a little different with a bunch more zeros in it, but you could always drop those zeros, right? And again, if you did it events home run in there, so you didn't make a new column, that's fine too. All right. And then because we've been doing it at the beginning of all these things, trying to reinforce column names, name changing, let's change is HR to home run count. Okay. So we have this thing called home run count now. Now the next part of the question is, for pitchers, what is their most frequently thrown pitch? So this is going to be another data frame. And we're going to use pitcher name, and then the pitch name. And then we could use any column. We could use is strike. We could use is HR. We could use whatever we want. But what we ultimately want to do is we want to group by and then count, right? This is just like how we did it before in a different problem. We just asked how many times they throw a pitch. You do group by count to get this information. And then you have a pitcher, and then in order to get how often they threw, you could do another group by if you wanted to. Okay, you could do another group by, and some people did this. I saw a couple people do it this way. This was like the first way I saw someone do this. And now, oh shit, hold on. That's not how they did it. How did they do that? This way. So I saw some people group by pitcher pitch name to get the count. And then they group by pitcher name only, and they got the max. So now this is giving how often the pitch that they threw the most. The pitch that they threw the most. So some people did it this way. And that's fine if you did it this way. Completely fine. You will get to the right answer this way as well. Another way you could do it would be all in one line. I think you could do this all in one line. I actually don't know. I thought you could do this all in one line. Can you do IDX max? No, that doesn't work. Axis 1? Close, no. Okay, you might not be able to do this all in one line. And that's okay. Okay, so we have one data frame with HR count, and another data frame, and this is for a pitcher, the max pitch, right? So I'm actually gonna change this name here. So DF2, we're gonna rename the is home run column to pitch count. I am throwing his fastball 73 times on his slider. Let me see. Fastball 73 times. Oh yeah, you're right. How would I do that then? So we're messing up the max. This is only getting the max. We would need to keep both. So I get the max, and then I join that back. Pitcher name. Pitcher name and actually on everything. That's fine. Oh, do I do it this way? No, it's still giving me this. Oh, wait. Lol. Okay. And this should have been fine too. Yeah, okay. I was printing the wrong line, chat. I was printing the wrong line. So we'll merge this. So there you go. Now the pitch type's correct. So we get the max number of times they threw a pitch. Then we merge that back. And we rename that to pitch count. So now we should have the right pitch name and the right number of times they threw it. So this should look good to y'all. Okay, so now we have one data frame that is the batter and the pitches that they hit for home runs. Then we have another data frame of the pitchers and the pitch type that they threw the most. Okay, so as you can imagine, we're going to merge these two things on pitch name. Okay, and we'll make this a DF3 because DF3 ends up being pretty big. Especially when like DF1 was tiny, DF2 also tiny. So now DF3, since we're joining onto just the pitch type, just the pitch name, it's going to blow up or expand out your data frame. Okay. So now, if we take a look at a lot of these, and you might have noticed this before, you're gonna get a lot of, you're gonna get all the pitchers who threw a four-seam fastball on a batter, okay? And this is like pretty large, right? Again, it's 20,000 rows, so if we even expand it out to 100, we still have Willy Adames, because there's 300 pitchers that it has to go through, and if they threw a fastball at all, so even at 200 here, we end up getting our next batter. I think maybe 150 is where we still have, yes, that's it. At 150 is where we get to our next time through the pitching order here. Now, we want to know which ones, what was it? After you join batters and pitchers together, after joining, check to see if each batter and the pitcher ever actually matched up against each other, and make a new column if they did or didn't. Okay, so this is actually, like, in my opinion, the fun part. So if we have just your regular DF and you have the batter name column and the pitcher name column, then technically, these are all the times the batter and the pitcher matched up against each other. Okay, these are all the times. Now, because it's at the pitch level, right, you're gonna get multiple times they matched up against each other. So it's important to know that you do have different aggregation and convenience tools. Like, for instance, if I just wanted a single row every time Aramis Garcia faced Brandon Hughes, how would I do that? And so this was something that you could have Googled. If you did a group by, something with a group by here, you could have done it that way as well. Like if you group by count, right, over something, that would have been fine. You could have absolutely done it that way. And some of you may have, but I'll show you something new here. You could do a drop duplicates, right? And now you get a single row with the name of the batter and the pitcher, right? As opposed to if I did no drop duplicates, I would get every time the pitcher threw a pitch to the batter. DF5, remember these are all the real matchups, so I'm gonna make a column called real matchup equals 1. All right, so now I have, I guess this is DF4. We're not at DF5 yet, DF4. Okay, so if I have my DF3, which is my merge of 1 and 2. So 1 was the batter stuff, 2 was the pitcher stuff, 3 is the merge over pitch type. So if a pitcher throws a pitch type and if the batter hits a home run off that particular pitch type. But not all batters faced all the pitchers, right? So now we're gonna look for DF4, all the times that they actually matched up in the data set. drop the duplicates, so we only have unique rows. Then we make a column called real matchup 1, because when we merge our batter pitcher pitch type data frame, DF3, with DF4, and we create a DF5, this is going to be a, what's the shape of this thing? So this is going to give us, this is a, what we call an inner join, right? So this actually ends up shrinking our data set, and it's also only giving us all the times where these real matchups happened. Okay, so Willy Adames actually faced Robert Duggar. Willy Adames actually faced Alexis Diaz in 2022. But that's not what it's asking. It's asking if they did or if they didn't, right? So one thing we didn't go over, and this is, again, number 3 is a little harder because it's the stuff that we're doing today. So if you did get it all, that's great. But we're going to be jumping into it for the day 4 material in a second here. So one thing we didn't teach is how, the way you join. So there's 3 different, technically 4 different ways to join. You could do an inner join. That's if the same things in DF3 and the same things in DF4 match, then it will create a join between like items, like values, and that's what the default is. It's this inner join. However, you could also do I guess the second most, maybe the most popular. The second most popular thing would be a left join, and this gives you all your column, all the data from DF3, your left data frame, and then DF4 will be joining onto anything that it can, and then everything it can't join onto, it's going to leave it alone. So when we take a look at our head again, you'll see that Willy Adames, all the times it says 1 is when Willy Adames faced someone for real, like Luis Castillo in this case. But all the times it says NAN, that's not a number, or that he didn't face any of these pitchers. So he only faced Luis Castillo, Philip Deal, Robert Duggar, Justin Dunn, Alexis Diaz, Buck Farmer, Luke Farrell, Ian Jabot. And this kind of makes sense because Willy Adames is not a Cincinnati Red, and all of these pitchers are Cincinnati Reds. Remember, our data frame is Reds pitching or batting, right? So this kind of makes sense. This lines up. Okay, so are these, is that what not, NAN? Yes, NAN stands for not a number. Not a number. That is what NAN stands for. Okay, so one way to get rid of that, matchup, is to save over it and fill NA with 0. Now you get 1s and 0s. And then if you really want to go one step further and get the decimal out of there, you could change the type. So you could force the type to int or integer. And now you get 1s and 0s without a decimal. If you leave it as a float, it's going to give you the decimal. For the most fancy people out there, you could change this to bool or boolean. And this will give you trues and falses. But any of those are fine. But this is ultimately the complete answer. So all the batters, the batter, the times they hit a home run, and who they matched up against, who throws the same pitch type. Nice. Okay, that was number 3. Let's go over 4 and 5 real quick. Those were a little easier. It's data viz. Question 4 is make a bar plot for 5 players and plot the amount of times they have thrown each pitch type. So I'm just going to grab 5 random players from pitcher name. So if I do pitcher name unique, You know, here's all the times there were pitchers. And so I'm just gonna grab 1, 2, 3, 4. Here's 5 of them right here. It's just pitchers here. Pitchers equals this list. Okay, so there's 5 pitchers. And then we're gonna make a bar plot. So bar plot for 5 players. Okay, so we'll create df loc, and then we'll say pitcher name dot is in pitchers. Remember we did this is in stuff. So we're getting our 5 pitchers. And then plot the amount of times they threw each pitch type. So we'll do pitcher name again, pitch name, and then we could use any column in here, like is strike. That's something we've been using for a while. We'll group by. As index. Some of y'all out there might be like, wow, we do a lot of the same things over and over again in this homework. You would be correct. You would be correct. Because in data science, you tend to do a lot of the basics over and over and over again. We'll call this dfplt. We did this before when we were creating plots. We give them a different, we give this a different name because we're about to plot the stuff inside of it. I'll drop this into something that's more readable. So we got the df loc, here's our statement, the count, the group by, and then the count. Okay. So now this is make a bar plot for 5 players. So if I go for pitcher in pitchers, I'm going to do data loc pitcher name equals pitcher. That's the data. And then x is strike. Oh, I should rename this. Let's rename this. Let's be good students and rename this. I told you homework review was going to be long today, but I think this is good. And we'll call this count. And we could take a look. So this is called count. So we could do count as x, and then y, we could do pitcher name, or pitch name. And then we plot this. So here are 5 plots, pitch name, and count. We also did a print before, because I don't necessarily know which of these plots belong to who. So we did this as well. We did a little print here. And we'll get more into the data viz stuff later on, but this is a quick and easy way to show. This is Keegan Thompson, how he threw his pitches. Here's Buck Farmer, Fernando Cruz, Javier Assad, and Ian Jabot. Okay, so there's 5 random players making a bar plot for 5 players. Now, some people, you could have gotten a little creative, okay? Creativity is good. If you made a bar plot and looked like this, that's fine as well. That's fine as well. No harm, no foul there. Data visualization is about how well you can communicate the information provided visually, succinctly and accurately. So if you did this either way, that's good. Okay, last question was using scatter plot the average strike and pitch type count. Use with the entire data set or a subsample of data. Okay, cool. Let's see what data we have available here. Strike average, so is strike plotted for the entire data set or for a subset? Okay, so let's go pitcher name. And you can do this for the entire data set, subset of data, however you want to do it. I'm just going to do it for pitchers. And then this is just plot strike average and pitch type count. Okay, so we'll use pitch name is strike group by. Again, we've done this like a bunch of times now, so I'm just gonna run through this. These are all things that we just did several times. This first one is count. This next one is average. Merge them both. I double check it. And then a scatter plot, which we didn't do, but I do tell you how to do it. So I say, make a scatter plot where X is the average and Y is the count. And I could do it for all the data. And it could look something like this. Here's the average, and here's the count, how often a pitch type is thrown. And if you want to look at a smaller set of data, like if you did is red's pitcher, right? You could have done it this way too. This was in the notes. You'll get something smaller. Check in with each other in terms of homework. Create study days. Treat it however you want to treat it, but I do recommend leaning on people and definitely lean at the very least. Me on these streams or in the Discord, in the Bootcamp help section. That's good too. Okay, day 4. If you made it to day 4, chat, if you're here and you're like, fuck, I'm keeping up with this shit, I'm doing pretty well, I feel like I'm ready for the next thing, way to go. Congratulations, you've made it to day 4. This is essentially the halfway point for the boot camp. All right, so congratulations, you've made it this far. If you're still with me, you've learned a ton of Python, and don't let anyone say anything differently. You've gone from spreadsheet world or wherever the fuck you came from, and you're able to open stuff up and do things as you would in a spreadsheet. You have one-to-one evidence that you can go from spreadsheet land to Python land now. All right, you have proven that to yourself. So definitely congratulations to you. You've made it this far. From here forward, that spreadsheet we were working off of, we're no longer gonna use this thing, okay? So let it be known, if you made it this far and you've been comfortable with everything to this point, this is where we cut the spreadsheet world out of the bootcamp life, okay? No longer do we need to use spreadsheet stuff, okay? And I'm gonna go over why, okay? For example, if you have the current data frame loaded, you had 49,000 rows available to you, okay? But now we're going to load in the bigger data set, okay? We're gonna load in the bigger data set. So just like how we did it before, let's go over some of the basic things like how to load in data. You should be, if you, in your shortcuts, you should be drive my drive mats. And the way to check that is your list dir that we did in day 1. If you type in drive my drive mats, and you run this cell, you will get something. I can't show you all the mats in my drive, but you should see something you should see those files pop up. In where this is stored for me is Drive My Drive data share. Something like this. Oh wait, is it here? No, that's not right. Mats, it's this. Must be next week's homework. So you should see something like this. So don't get tripped up too much on the folder name. This is just folder path stuff, okay? So we're going to load in, we're not gonna load in reds anymore. We're gonna load in the other data set. Okay, so 2023 NWBC data.csv. Okay. So let's say bye-bye to the reds.csv, this 49,000 row data set we've been using. Let's say goodbye to that. Let's load this in, and don't, from here on out, make sure you use .head and .shape. Do not try to print your entire data frame. Don't do that. So let's load in our gigantic 388 megabyte data frame. Let's load this in. It's gonna take a couple seconds to load in because it's a lot of data. It's a lot of data. And once it's all loaded in, you could do a df.shape, and you can see right here, we're going from 49,000 rows, and we're going up to 736,000 rows. Okay, just shy of 750 million rows, or 750 million rows. Not my compute, not my problem. Exactly. If you're in Colab, this should not affect you. If you're on local, this is going to be a little more hardcore. Okay, so a couple things here. Have you ever tried to load hundreds of thousands of rows into Excel or Google Sheets before? The answer is no, you haven't, because Excel or Google Sheets will crash if you try to do this. So I strongly recommend you not do that. We're headed towards the stats part of the sessions, okay? The math today is gonna be pretty easy, and then on Thursday, we'll dive in a little deeper. But the first thing we gotta do, just like we did in the homework chat, we gotta remake some of the columns, because notice how we have 95 columns and we don't have 100 columns? We gotta remake some of those columns that we really liked. So feel free to go back to day one and let's remake that is strikes column. So feel free to go back and copy all that code. I'm going to, or if you want to rewrite the code, see if you can kick it from your brain, you could do that too, or if you want to follow along with me, you could do that too. I am going to straight up copy some of these things because we've done this already. So if you've been here at day one, you should remember all of this stuff. Strike events, making the new column. We make so many new columns, right? So now I'm not gonna force everyone to use 700,000 rows, okay? We're gonna parse this down a little, that way it's not just completely absurd and obscene. Let's make a temporary data frame. And the first thing we wanna do is let's count the amount of times a pitcher throws a pitch type. So we'll say df loc, and we'll select pitcher name, pitch name, is strike. We've been using that for a while. We'll group by. It's as if we've done this 5 or 6 times already. And you know, that's how it's set up. That's how it's set up. And then we were renaming this on another line, but I'm just gonna actually put the rename at the end of the group by statement. So you actually don't have to The nice thing about Python or pandas is you can do a lot of things in one line. Okay, and then I'll save this as I'll put this in a temporary data frame or underscore df. So sometimes you'll see in Python underscore variable name. A lot of the time that means temporary variable. So you don't really care if it gets overridden. It's just there temporarily. Okay, and then I have this loc, pitcher name, pitch name, is strike, the group by. We're counting how many times each pitch type was thrown. And then we're renaming is strike to number of pitches, so the amount of times it was thrown. We could take this column and let's merge it back, because we learned about merging. Let's merge that back onto our original data set. Okay, and remember, the columns that we have here are pitcher name and pitch name, and then we have number of pitches. So let's say on pitcher name and pitch name. I'll make this merge, and we'll call this df2. Okay. So if we look at df2 dot head, this merge might take a second because it's pretty big. You'll see at the end here, number of pitches for this pitcher and for this pitch type, which in this case is a slider. But the pitch name, it's buried in here in one of the columns. So this pitcher is throwing this pitch type over the course of the season 572 times. One more step, because this is a lot of rows. If you look at df2 dot shape, this is a lot of rows. Let's limit this down. Sometimes we don't care so much about smaller sample things. If we want to do statistical inference, or if we want to do some sort of math or something, something that's important is limiting your data set to what's called like some minimal threshold or qualifying value, right? A lot of the times in the pitching world, for one pitch type, it's hard to get like any information if a pitcher only throws it like 1, 2, 5, 10 times. It's hard to really know, like, is this good pitching? Is this a pitcher who pitches well? Or is this just noise, right? So let's make a pretty high threshold of n pitches. So we created this count, right? We created this count here. And then we merged all of that together. Let's make a threshold where you have to throw a pitch type, right? If you're a pitcher and you throw a particular pitch type, you need to throw that over 100 times. Okay? You need to throw that over 100 times. And then we'll create df2. Or overwrite it. So now when we look at df2.shape, we have slightly less pitches. So we're not working with 700,000 pitches. We're now working with a little less than 700,000 pitches. So we have people who have qualified pitch. And then one more thing, just because we did it before, we're gonna make a new runs column. So ultimately what we'll do at the end of today is we're actually gonna create ERA, and then we'll create some other columns, and ultimately we'll have a couple different rows of data that you would typically see, like ERA, strikeouts per 9, and then hopefully we'll end with a little math here. So a lot to do in 20 minutes, but a lot of this should be review. Let's also create runs scored, right? So if we're trying to create like what's the quality of your pitch type, we might need like, all right, how many runs were scored if you threw this particular pitch, right? Like in the homework, question 3, when we did the batters and the pitchers, when they matched up. Did a batter hit a home run? Did a pitcher throw that pitch type? Some pitchers matched up for real. Which one of those pitchers actually threw the home run? That's something we don't know. So this is sort of the next step. Well, maybe we shouldn't use like a batter-pitcher matchup for this. Maybe we could do it more directly with how many times did the pitcher throw a pitch type and they gave up runs. So let's do runs scored. And this is actually pretty easy in my opinion. So there's a column called bat score. Okay, there's a column called bat score. And that's how many runs the batting team, the team that's at bat, has scored at that point. There's also post bat score, which is after the pitch is thrown, how many runs were scored. Okay? So we can actually do a subtraction. We could do a subtraction here, post bat score minus bat score, to get runs scored. So 600,000 rows, now 98 columns. Sometimes you'll get this like, try using .loc. Don't worry about a warning like this. I know I'm doing the subtraction here. This is causing it. So we're just doing some math here, no worries. Okay, so if we do df2.head, we'll see runs scored, that's a new column. df2 head 50, none of the first 50 rows have a run scored on the given pitch. Okay. Scoring runs is hard in baseball. So another way to check this, it's a pitcher's duel, exactly. You can do runs scored, and you can look at the mean, which will give you like, on average, how often is a pitch thrown and a run is scored. You could also do like max. Max is 4, right? Grand slam, 1 pitch, 4 runs scored. You could do min. Min is, of course, 0 runs scored. If you wanted, say, a statistical summary of all this information, you can actually do something called .describe. And .describe actually gives you a summary of statistics for a numerical column. So if I wanted to know, like, runs scored, like I wasn't able to see to validate, like, oh, is there any numbers being put into this? Did I subtract zeros from zeros? There are other ways to validate whether there's information in your data, right? So if you do df2 runs scored .describe, this gives you how many rows of data there are, what the mean is, what the standard deviation is, your min and your max, and then these values here are your quantiles. And for those who really know statistics out there, this is your interquartile range. So this gives you a good description, statistical description. Something that's out there that everyone hears about, one of the first pitching metrics, pitching stats that you see on TV, that you hear reported all the time in terms of the quality of a pitcher, is their earned run average, or their ERA. So we're gonna create an ERA data frame. The first thing we wanna do is we're gonna group by. And we're gonna group by a couple different ways. I'm gonna teach you a couple new group by techniques right now. So the first one, I'm not gonna teach you anything new. We're doing the same shit we've did and we've been doing, but we're gonna use runs scored this time. Okay. Group by pitcher name and pitch. You could just group by pitcher name. All right, this is the first new thing. Since we're using a larger data set, there might be like multiple John Smiths. There might be multiple Luis Castillos, and there are. There might be multiple names. So we can't just use pitcher name anymore. Something that's been in our data set is a unique ID. So if we have pitcher name and pitcher, and we do drop duplicates, so we only see unique rows, and we'll do a head. You can see in the first 20 for pitcher name, they have a name and an ID. So here's Lance McCullers, Ranger Suarez, Zach Wheeler, Luis Garcia, which was just said in chat. And they have this pitcher ID, which is just the pitcher column. So this is their unique ID. That way you don't have people with the same name messing up your data. Now you have name and a unique ID. Okay, so let's go back to our group by statement. I'm gonna group by pitcher name and their unique ID, pitcher, and then runs scored. This is as index false. And then we're gonna add. So all the times that a run was scored on a particular pitch, on a particular pitcher, we'll just add up all the times a run was scored. All right, and we're gonna start this off as our the beginnings of our ERA data frame. Okay. Let's make this look a little nicer. So you should have a loc, a group by, and a sum. Okay, next thing. In order to get the number of innings, remember our data set is in one row is one pitch. So in order for us to get the number of innings, we need to do a little work to get there. So I'm going to show you some new techniques here in order for you to get innings instead of number of pitches thrown. Since ERA, earned run average, is contextualized by innings, not by pitches. Also important, so important for female athletes who often change their last name. Yeah, exactly. So a few things. In order to get innings, we need to do several things. So let's look at DF2, and the first thing we need to do is for our pitcher, and let's just use pitcher ID. We don't need pitcher name in this case. So for a pitcher ID, we want to know for a game, how many innings did they throw in that game? And then we're going to sum all the innings that they played over each game to get the number of innings they threw in the 2022 season in this data set. Okay, so for one game, if they played in 6 innings, and then the next game they played in 5 innings, and they played only 2 games in the entire season, then we would get 11 innings in the season, right? So that's sort of the logic we're going for here. So a couple things in our data set. So if we look at our DF columns, if you want the innings, you could always get inning. But if you want the game, right, you could use game date, but game date's hard because there's the same games played on the same dates. So if only there was an ID for the game as well as there is an ID for the pitcher. Well, luckily for you, there is an ID called game PK. Game PK. This right here, game PK. And on the StatCast documentation, if you search, where the hell is it? Here it is, game PK right here. This is the unique ID for the game. So for every game played, they have a unique ID, just like how for every pitcher, there is a unique ID for the pitcher. So game PK. So for each game, we want to know how many innings, a pitcher threw in, okay? So we did this before with our pitcher name and pitcher when we did drop duplicates, right? So we dropped the duplicates and we got one row, one pitcher ID with their pitcher name. We could do that again here. So if we do pitcher game PK inning, drop duplicates, right? And we can put this into a temporary data frame. And we take a look at the top 20. We could get the pitcher ID, the game, and the inning number. So a unique inning number in this game. So we have a pitcher, and for each game, this is an inning thrown. So for each row is 1 inning. We'll treat it as 1 inning, right? So this pitcher threw 1 inning here, and this pitcher, same ID, threw another inning here. And so if we were able to count the number of times 571, 479 was represented in this one column, then we would get the number of times this pitcher pitched in an inning, right? So for every 1 row, it's 1 inning pitched. So we can use a group by if you want. You could count over this stuff. You could do all that stuff. But there's actually a faster way to do this. And I'll show you a new technique within the columns. So we do all this group by stuff in the data frames. It's actually pretty expensive inside data frames. But if we wanted to count how many times this pitcher ID occurred inside of this column, we could count the values, how many times those happen, just like a group by count. We could count those values by using a function called value counts. We could use something called value counts. And so for a pitcher with this ID, this is how many rows or how many times this pitcher ID occurred, right? And in this case, for this pitcher ID, it was counted on 241 times, which is the same as saying this pitcher ID threw 241 innings, roughly. We took our data frame, we made unique game innings, and then we did a value count over the pitcher, how many innings the pitcher threw in the 2022 season. Okay, so this is value counts. Now, of course, as you're thinking, all right, well, we need to join this information back onto our ERA data set, right? ERA is sitting there, and they have a pitcher ID column. We got to merge value counts over onto it. Okay, but in order to merge it, we still need a data frame. So we got to do a couple things in order to turn this column of data, this pandas series. So a column of pandas data is called a pandas series. So we need to turn this series of data into a data frame. Okay. Luckily, we could chain together another function called toFrame. Pretty convenient. Now we have a data frame and not a series of data. So we have pitcher, and then the number of times this pitcher ID was in the inning. But the pitcher IDs, right, are in the index. Just like how we did before, if we need to take something out of the index and turn that into a column of data, we can reset the index. Okay? And so if we do reset index, now the index column, which was once the index here, this index column is the pitcher ID. And then the pitcher column is the number of times that pitcher threw in an inning. Or sorry, the number of innings a pitcher threw in a season. Okay, and one more thing, something that we've been doing for a bit, rename columns. And we're gonna rename both of these columns. Index will rename to pitcher. And this is something we haven't done yet, so we're doing this here right now. We're gonna rename another column in the data set. We're gonna rename that pitcher column to N innings, which is short for number of innings. Okay, and the way we did that was index colon pitcher, comma, pitcher colon index. So this is The squiggly lines, we talked about this before. This is a form of data in Python called a dictionary. So this is a way we could store data, just like a list. You could store items inside of a list. You could store keyword, key value pairs in a dictionary, right? So renaming index to picture, and then the next key value pair, comma separated, just like how in a list you have comma separated values. In a dictionary, you have comma separated key value pairs. So key index value picture, a new key value pair, key picture value, and inning. Okay, so we have this data frame, okay, this new data frame, and let's overwrite our old data frame. Because it's just a temporary data frame. We don't really need to use it for anything other than joining. And I'll just break out these chained values here, and then also push this down a little just to get a little more clarity. So we're creating a new data set called ERA because we want to calculate earn, run, average. We do our group by over pitcher name and their ID, and then we're summing over the runs scored. So how many times this pitcher gave up runs in the season. Then we have this temporary data set now, data frame, where we got unique game innings for each pitcher. Then we did a value count over pitcher, converted that into a data frame, reset the index, and then renamed our columns. And now is the magical merge. Okay, and you could just do it this way and it would actually work. If you just did it this way, you would get a pitcher name, their pitcher ID, and then runs scored over the course of the season and the number of innings that they throw. Right? If you just did this merge like this. But since we're teaching good coding practices, chat, okay, let's do on pitcher, because we have pitcher in our data frame, in our temporary data frame. Remember, the only thing in this is our pitcher ID and then the number of innings thrown. So we'll merge onto pitcher. And this is the same thing. You'll get the exact same thing, the exact same behavior. It's just more explicit. That way when your first data science manager, data analytics manager looks over your code, they aren't yelling at you about doing implicit joins. You explicitly stated, we're joining on pitcher here. Okay. All right, everyone good up to this point? We'll do one more thing, and then I'll give you some homework. Okay, one more thing. I can't let you all hanging, you know? I can't let you all hanging. Let's create ERA. Okay, we got all the data. It's time for us to create ERA. ERA is runs scored divided by the number of innings. Okay. Remember, this is just like any math, so make sure you wrap that in a parentheses, and then you're going to multiply through by 9, right? So this is runs per inning scored, but ERA is contextualized over an entire game, so earn, run, average. The average in this case is over the course of a full game of innings. What is the, how many runs would you give up? And we went over this a couple times already. We're really not being accurate because we're limiting it to pitch types only thrown over 100 times, right? So that's the first thing. This is already not going to be accurate because we're not including all pitches. The second thing is we're also counting partial innings as full innings, right? That's this. we're already counting partial innings as full innings. So don't get too caught up on the details here, right? The important thing on all of this is you are learning how to do stuff in Python. So when you do ERA runs scored divided by the number of innings times 9, you should start seeing your ERA. So now you have runs scored, number of innings. If you contextualize it over 9 innings, you now have something that looks like ERA. We are using the full season of data now. We're not just using Reds data times the Reds were at bat or pitching. We're using all of the 2022 season in this case. Kind of. So this is each pitcher in the entire season who threw a pitch type 100 times or more. Okay, so homework. All right, the statistic strikeouts per 9 helps contextualize how often a pitcher strikes out their opponents. Calculate strikeouts over the course of a game. Calculate strikeouts per 9 by adding the number of times a pitcher strikes out an opponent, divide by the number of innings they threw in, then multiply by 9 to normalize the statistic over 9 innings for each pitcher. Calculate K per 9 at the game level for each pitcher. Not at the game level, at the season level. The season level, right? It's just like ERA, except instead of runs scored, you want to calculate strikeouts. This is similar to ERA. This is mandatory homework. We will use this column in the next day. Or the next day. Yes, this is mandatory homework. Fielder independent. Pitching, aka FIP, is similar to ERA, except it tries to utilize only the events a pitcher has control over. Home runs, walks, and strikeouts. The equation of FIP is roughly FIP equals frac. At the top we got 13 times HR. Grad school's coming back to me, baby. 3 times walks, 2 times K, and then innings pitched, plus 3. The equation of FIP is roughly this, okay? Where HR is home runs, BB is walk, and K is strikeout. Using the ERA data frame, calculate FIP for each pitcher. Okay, one more. Explore the Seaborn Gallery page and try visualizing the relationship between ERA and FIP. You can use something like joint plot or KDE plot to visualize the relationship between FIP and ERA. If you don't want to use only a scatter plot. You use something like joint plot or KD plot. Okay, I think that's good. I think that's good for homework. I'll post this homework in Matt's. Good night, campers. I gotta go.